Today we're going to be looking at two examples of using the integrating factor method to solve first-order linear ODEs. The two most common mistakes people tend to make are forgetting to do step 1, which is to rewrite the ODE into the correct form where y prime is by itself, and step 2, in the case where the ODE takes the form of y prime minus p of x, y equals a of x, they tend to use p of x and not minus p of x when finding the integrating factor. I encourage you to pause the video and try solving the example on your own, and then we'll walk through the workings together. For our first example, we can see that we've got a first order linear ODE, so we can apply the integrating factor method. The first thing you'll want to do is check that y prime is by itself. Here we can see that it is, so we don't need to divide by anything. The second thing we'll want to do is to find the integrating factor, which we'll call I of x, and that is just equal to e to the integral of the term in front of the y. Here that is just 2 dx, and this just equals e to the 2x. Now we can multiply both the left and the right hand side by this integrating factor. So we'll just get e to the 2x y prime plus 2e to the 2x y equals x e to the 2x. Now we can apply the reverse product rule and we'll just equal d dx of e to the 2x, our integrating factor, multiplied by with y. And this will just equal our right hand side, x e to the 2x. We can take the integral of both sides. So if we say the integral of d dx e to the 2x y dx equals the integral of x e to the 2x dx. You'll see on the left hand side the derivative and the integral are going to cancel each other out. So we're going to just be left with our integrating factor multiplied by with y. And that's always the case. So I often skip the previous few steps and just go straight to the integrating factor multiplied by with y equals our integral of x e to the 2x dx. Here we need to apply integration by parts, and doing that we're going to get e to the 2x y equals x over 2 e to the 2x minus 1/4 e to the 2x plus our constant of integration c. Now we can just solve by y by dividing by e to the 2x, and this will just give us y equals x over 2 minus 1/4 plus c e to the minus 2x. Now this is our general solution, and we have an initial value problem, so we need to go one step further and plug in x equals 0 and y equals 1. So doing this, we get y equals 1 and x equals 0, so that term vanishes and we get minus 1/4 plus c, and if x equals 0, that e term goes to 1, so we just end up with this, and solving for c, we get that c equals 5/4. So we can write our specific solution, y equals x over 2 minus 1/4 plus our c, which is 5/4 e to the minus 2x. And this is our specific solution. Let's try another example. Here we have a first order linear ODE, so we know that we can apply the integrating factor method. The first thing we'll want to do is check that y prime is by itself. Here we can see that it's not, so we need to multiply both the left and right hand sides by cosine of x. This gives us tan of x times y equals minus 1 over cosine of x. Now we can find the integrating factor. We'll call this I of x. And that's just equal to e raised to the integral of whatever is in front of the y, in this case tan of x, dx. Now, simplifying this, we just get e to the natural logarithm of cosine of x, and that just equals cosine of x. Now we can multiply both the left and the right hand side by cosine of x. And we can see that our cosines here will cancel. So we'll just be left with cosine of x, y prime minus sine of x times y equals minus 1. Now on the left hand side, we can use the reverse product rule, and we can write it as d dx of cosine of x multiplied by with y, and that will just equal our right hand side -1. Now what we can do is we can take the integral of both sides, so we'll get d dx of cosine of x y dx equals the integral of -1 dx. Now on the left hand side, our integral and our derivative are going to cancel each other out, and we're going to get our integrating factor multiplied by with y, and that is always the case. And so now we can just solve our integral on the right hand side, remembering to add in our constant of integration, and now we can just solve for y equals minus x plus c over cosine of x. So here is our general solution. But because we have an initial value problem, we also need to plug in x equals 0 and y equals 1. So if we do that, we get 1 equals minus 0 plus c over cosine of 0 is just going to be 1. So we're going to end up with c equals 1. Now we can write our specific solution. Y of x equals minus x plus our constant 1 over cosine of x. So this is our specific solution. But there's an important qualification here, and that is that x is between minus pi over 2 and pi over 2. Because our denominator is cosine of x and our denominator cannot be 0, and our initial value x equals 0 lives in that interval on the unit circle, so that's why we choose this interval. If you liked the video, then please give it a thumbs up. If you found it helpful, then feel free to subscribe. I make regular videos on calculus, linear algebra, statistics, psychology and physics. As always, thanks for watching.